Hello students, today we are going to discuss an important reaction by name ozonolysis in alkenes. By the name itself, alkenes are subjected to reaction with ozone. Later on, reaction in the presence of zinc and water undergoes lysis to give carbonyl compound. Very simple reaction. It is a two-step reaction where ozone reacts with alkene to give ozonite. The form ozonite reacts with zinc and water, which undergoes lysis to form carbonyl compounds. Carbonyl compounds are aldehydes and ketones. So basic name corresponding to ozonolysis is using ozone, and that leads to breaking or lysis of compound to form carbonyl compound, that is aldehyde and ketones. A basic example we can use here is ethene undergoes reaction with ozone in the presence of zinc and water that leads to breaking of double bond, and wherever there was a double bond there will be formation of oxygen. That means this part reacts with O and even this part reacts with double bond O. So the compound is broken and that leads to formation of carbonyl compound. This is carbonyl compound. This is CH2 double bond O, can be written as HC double bond OH, and this compound is called as formaldehyde. Even this compound is also formaldehyde. So there is 2 moles of formaldehyde formed when ethene reacts with ozone in the presence of zinc and water. But ozonolysis is actually helpful for some reason. What is it is used for is very important. Ozonolysis was used for locating the position of double bond. How do you do that? For example, there are 2 compounds formed after ozonolysis. Those compound name is CH3, CH3 double bond O, and CH3 double bond O. So wherever there is oxygen present attached to carbon, that carbon is called as oxygenated carbon. So the carbonyl compounds formed after ozonolysis can be used to determine the parent compound. For example, these are the products. I want to know from where they were actually originated. I mean to say which alkene was actually subjected to ozonolysis in the presence of ozone and zinc and water. So we can use these 2 compounds for that. What are we going to do is, only thing is, we are going to join these 2 carbons by omitting the oxygens, by removing this oxygens, just by joining this compound, that is CH3, CH3. I've taken this part, double bond, oxygen is removed and oxygen is removed. Then we are going to take only this part, that is carbon with hydrogen and CH3. That means that these 2 compounds were derived from this particular alkene. If I want to name this compound, I have to number from here 1, 2, 3, 4. At second position I have methyl, 2 methyl. At second position we have double bond, 2 butene. So this was the parent alkene which was subjected to ozonolysis in the presence of zinc and water. That resulted in breaking here, and I'm going to get CH3. This is CH3 I'm writing. Then on second carbon we have CH3. Here at this part we are going to add double bond O plus exactly this part I have to write CH3 CH double bond. This is acetaldehyde. This is acetone. Very simple reaction. Ozonolysis. What are we doing? First thing is we understood that what is ozonolysis. Ozonolysis is a two-step process. We are not trying to explain all the two steps, just we need to remember it is a two-step process which uses O3 and forms ozonite. I'm just going to show you what is ozonite in a general mechanism, and this ozonite reacts in the presence of zinc and water to give carbonyl compounds. What is the use of the compound formed after ozonolysis? If we join the oxygenated carbon as we have done here, we'll get to know what is the parent alkene or the structure of alkene which was subjected to ozonolysis. Now, general alkene, if we have this general alkene in the presence of an inert solvent and acts on ozone, we are going to get here one oxygen, then carbon with two bonds as it is, oxygen, and here a bond. This particular structure is called as ozonoid. Ozonoid. What are we doing? We are just breaking this bond from here and then adding up oxygen, one oxygen here, one oxygen here, one oxygen here. That's it. A structure. This is how ozonide is formed. After ozonide is formed, it is subjected to lysis in the presence of zinc and water, and there is a breaking here. One of the oxygen will be lost. This is transferred here. This is transferred here. I'm just writing two carbons, this one as it is, and if this bond is shifting here, double bond O. I'm writing this part exactly as it is, two bonds to the carbon. If this bond shifts here, double bond to oxygen. So these are the two carbonyl compounds. And one thing to remember here, the carbonyl compound which can be aldehyde or ketone depends on the structure of alkene which we are going to use. Depends on the structure of alkene which we are going to use. This is what is the process of ozonolysis. Very small reaction, very important reaction, very simple to understand. It is a two-step process. It begins with reaction with O3 to form ozonite, which is subjected to lysis with the help of Zn and H2. That is why the name ozonolysis, to generate carbonyl compound. We have seen the example of how 2-methyl butene gives acetone and aldehyde, which is a two-step process. I'll just remind you of this step what we have used. I'm going to use this compound that is 1, 2, 3, 4, 2-methyl 2-butene reacts with ozone in the presence of zinc and water. Here oxygens are going to be added, CH3 double bond O. This is CH3 C double bond O CH3 acetone plus CH3 CH CH3CH double bond O. This is acetaldehyde. This is what is the reaction for 2-methyl 2-butene, which gives acetone and acetaldehyde. I have already said you that the product form can actually be helpful. That carbonyl compound form can actually help us in knowing the structure of alkene. That is CH3 C. This is oxygenated carbon. C double bond O CH CH3. I can write in this way also. This is also oxygenated carbon. If I join them and remove this oxygenated oxygen from there, then it is CH3 C CH3 double bond C. This is a double bond C. CH CH3. Sorry. This part is as it is, CH3. Then here is, I have written this one wrong, I think, sorry. What is here is C CH. CH can be written as like this also. That is CH double bond O CH3, that is acetaldehyde. This part is removed. I am going to add CH single bond CH3. The compound name is 2-methyl 2-butene. I'm just trying to explain you that once again. The entire thing is almost same. This is the part of ozonolysis. I hope you will understand it. If you have got any doubts in it, you can just message in the WhatsApp group. Thank you.